That's very impressive.
All right, shut up. Do we want to punish Caruso?
Yes. Give him a chance. 5 minutes to come in here. Because he's late.
He's already 5 minutes late.
Oh, yeah. I thought the class started at 10:10. Okay, do it.
I'm thinking we do an attendance quiz.
I like it.
We haven't done one of those.
All right, somebody's got to donate a piece of paper. Start it in the back corner, pass it around, just everybody put their name on it. I'll give you a free quiz. This is to make up for our missed class last week. I promise you I was very ill.
Considering what you posted,
Like in the hospital ill.
Yeah, how are you better now?
I'm mostly better. I'm feeling a lot better.
Did you find out if they were actually ice?
And we were betting on Wednesday. You were betting Wednesday. We were gonna have class.
I thought I was going to be better. I don't like to cancel class.
I know you don't. That's like the third time.
Okay, so let's go through the homework assignment. So we have two different assignments we need to cover, right? First one was to reverse an array. So we're going to create an array initially, and that one's to take in a char array. So I'll go ahead and create the array. So I'll say char array AR is equal to, we'll just hard code it, H E L L O. All right. So we have this char array. Then we're going to go ahead and we're going to print out that array. And I mentioned to you last class that the system.out.println, the println method, happens to know how to display character arrays. Remember that we have polymorphism exemplified there where we go into the documentation. There's a whole bunch of versions of println. One of them knows how to take in a char array and display it. Okay? So we'll go ahead and print it out. Then we're going to make a call to our method. And what our method should do is it should take an array in as a parameter, reverse that array, and not return it. Okay, we're trying to understand the idea of pointers. Okay, we are changing the array in memory. So we're going to reverse it in memory so that when we come out of the method, we can just print it again and see that it actually has permanently changed. That make sense? So just to run this real quick, we create our array. We'll go ahead and print our array forwards just to show that it's working. So there's that guy. There's our array forwards. Now, something I've been saying to many of you who've been asking questions, you have to draw pictures. If you just sit down and you start guessing at what you need to do for the solution, I used the example with him last night. If I asked you to build a shed, okay, you would sit down and plan out the shed first, then start building it, right? You wouldn't just start randomly cutting wood and hammering it together and hope it turns into a shed. Many of you are taking that approach with these programming assignments. You just start throwing if statements and for loops in there and hope it somehow comes out to the answer magically. You can't do that. You have to understand the solution first before you ever start writing the code. I think I said this earlier in the semester. Next semester, you guys are going to be taking a class. You'll be taking my class as well, 300, but along with that, you'll be taking 370 with Dr. Locklear, and that's software engineering. And software engineering sounds like it would be a programming class, right? You'll be actually writing very little code in there. Most of what you're going to be doing in that class is designing solutions to problems. So in industry, we kind of have two different players. We have systems analysts, programming analysts, and then we have programmers. The system analysts solve the problems, put it into some sort of format that you can then hand to a programmer, and the programmer just basically paints by number. They have to use their brain too to do a little problem solving in there, but they're really taking a pre-solved solution and turning it into code. In fact, there's actually software engineering packages out there that if you design it correctly, it will code itself. If you put it in the format that it understands, it will code it itself. I think somebody missed the writing thing back there. So that's an important thing to consider. You have to solve the problem first before you ever start coding it. Okay? When I sit up here and I just solve the problem, I'm not just guessing. I've done this so many times and I'm going through that process in my head of solving the problem. Most of you are not at that point. You're going to have to draw out pictures and understand the steps you need to take. Where does this need to go next? Up here? You need to understand the steps that you need to take in order to solve the problem. Then you start grappling with the code that emulates those steps. Make sense? So, I'm going to go ahead and draw a couple pictures. Actually, I'm going to steal. Just so happens.
Does anybody?
Thank you. So what I've done here is I've created a character array named AR, and I set it equal to those elements. Okay? So this is equivalent to creating a character array AR. Char array AR is equal to a new char array 5, and then filling up bucket 0 with an H, bucket 1 with an E, bucket 2 with an L, so on and so forth. Okay? So this is just a convenience way of creating an array if you already know the contents of it. Probably don't want to do this unless you have a relatively finite number of contents. You probably wouldn't want to hard code an array like this if you were putting 1,000 things into it. You could, but you probably wouldn't want to. You'd probably want to read those things from some other source and fill in the array with them. All right, so by doing this right here, this one line of code, that produces something like this. This is the data structure that was created. So a variable named AR that holds some memory address. So this guy is a pointer. That pointer points into memory where this actual array lives. All right? Points into memory where this actual array lives. That's what we've created so far. Now, for reverse, we're going to write a method that takes in a character array. So I have another variable. I have a variable named I that's going to point to the same place as the array we pass it. So for instance, I'm going to go ahead and call my reverse array class method or instance method. Class method. How do you know? Static. How do we call class methods? Name of the class in which the method was defined. So HW dot reverse array. The array we're going to pass it is an array named AR. So AR is going to get passed in, and it's going to be associated with this local variable in this method called I. So what we just did there is we now have two variables that point to the same place. Make sense? So AR, back in our main method, points to this array up in memory. And now our local variable I also points to this array in memory. They're both pointers. All right? Now, our job is to reverse this array. So what do we need to do? We need to create a brand new array that's the same length as the original one. And just to keep our numbers easy, we'll say this guy starts off at memory address 200, 202, 204, 206, 208. Okay, so I'm going to need to create a brand new array. So what I'm going to do here, I'm going to create a char array. We'll call this guy temp. This guy's going to be a new char array. I want it to be the same length as I. How many elements are in I? I.length, number of elements. In this particular example, we know that it has 5 in it. But this method, a method is a reusable chunk of code. It needs to work on any char array I pass it. So how many elements are in I? I.length number of elements. That make sense? Okay, in this particular case, this will boil down to 5 because I'm calling this method passing it AR, which has 5 elements in it. Okay, so I just created another char array called temp. Okay, so I have 3 variables floating around out here now, right? I have AR, which is my pointer in main that points to my original array. I have I, which is my local variable inside my method, which happens to point to the exact same place in memory as AR. And then I have temp, which is a brand new array that doesn't have anything in it. Okay? So what I want to do is I want to fill up temp with the contents of AR or I. Those are synonyms for each other, right? Okay? But because of variable scope, I don't have access to AR in here. The way I access the array that AR points to is by my variable I. Okay? AR is a local variable to main. I'm now inside of this variable scope, which only has 2 variables, I and temp, that I have access to. Make sense? So my way of getting at that original array is through my variable I, which we know points to the same place as the array we passed it from main. So I need to go through this array and fill in this array backwards. So I want the O to be here. I want the L to be here. I want the other L to be here. The E to be here. The H to be here. All right, so I'm going to set up 2 counters. A counter that's going to go through I from beginning to end, and a counter that's going through temp from end to beginning. Make sense? So we're going to create an int pos, and we're going to start this off at 0. So I have another variable now. So here's pos. We'll start pos off at 0. Okay? Now, pos is going to take me on my voyage through temp. It's going to go from 0 to 1 to 2 to 3 to 4. Now I'm going to have a loop that's going to go through I from the end to the beginning. Kind of like walking through a string backwards. For int, I'll call this guy k, because I've already used the variable name I, which has traditionally been our counting integer, right? So you call this one k. So for k is equal to, what's the last legal bucket? I'm going to start it right here. What's the last legal bucket in I? I.length minus 1. Good. So for int k is equal to I.length minus 1. We're going to keep going as long as we are greater than or equal to bucket 0. Make sense? Keep going as long as k is greater than or equal to 0. And each time through, subtract 1 from k. So now I have another variable. Named k. And in this particular case, for our example right here, k will start off as 4. Okay? So we're drawing this picture so we can understand what's happening in these variables so I can make the appropriate code. So if I go to I at bucket 4, where do I want to put this O? I want to put it here. That is temp at bucket pause. That make sense? So I'm going to say temp at bucket pause equals I at bucket K. Then I need to add 1 to pause. You could have actually done this whole variable pause inside this for loop. I'm just kind of doing it in a way that's going to be more familiar to us right now. So we could have defined 2 separate variables right here and then changed 2 separate variables here. But this for loop is in a structure we've dealt with many times, and I've just thrown an extra little integer here for us to count the other guy. All right, so we're going to say temp at bucket pause gets the value of I at bucket K. So here's temp at bucket pause is currently 0, gets the value of I at bucket K. Make sense? Then pause gets 1 added to it. That's where I say my pause plus plus. So pause goes from a 0 to a 1. Our loop says that K gets 1 subtracted from it. So K becomes 3. Is 3 greater than or equal to 0? Is K greater than or equal to 0? It is. So what will we do? We'll set temp at bucket pause equal to K at bucket, I at bucket K, which is an L. Add 1 to pause is 2. Subtract 1 from K, K is 2. Is 2 greater than or equal to 0? Yep. So we're going to say temp at bucket pause, temp at bucket 2, this guy right here, is going to be equal to I at bucket 2, which is our next L. Add 1 to pause, subtract 1 from K. Is 1 greater than or equal to 0? Yep. So we're going to say temp at bucket pause, temp at bucket 3, is equal to I at bucket K. There's our E. Add 1 to pause, subtract 1 from K. Is 0 greater than or equal to 0?
No.
It is. It's equal to it. So we'll go through one more time. We're going to say temp at bucket pause, which is 4, is equal to I at bucket K, which is 0. So there's our H. Add 1 to pause, subtract 1 from K. Is K greater than or equal to 0? It's not. So we're done. Would you agree that currently temp holds whatever was in I in reverse? It does. But remember, requirement for this assignment is our method returns nothing because we want it to change in memory. Okay? Couple ways we could have done this. You could go back and copy everything back into the original location. Or can we make I point to temp? Let's think about this. What happens if I say this? What happens if I say I gets the value temp? That's going to overwrite the pointer stored in I with whatever the pointer is in temp. So now I and temp both point to the same place. Correct? Now the method ends. And I go and I print out AR again. what's going to print out? Where does AR point? AR points to hello in the right order. This is where it points. See the picture we drew? Okay. Is this the correct answer? We did all this work and then abandoned it at the end of the method. Correct? So when we created this temporary array, we did it because we know we're going to have to overwrite this guy. And the way we can overwrite that guy is by accessing it through I. So we're going to go ahead and loop back through this whole array, filling it up with whatever we have in temp. But you understand why that didn't work? We can see it clearly through the pointers by drawing the picture. So we need to set I, which points to the same place that they are, to the same contents as temp. So we're going to have another loop for int k is equal to 0. K is less than I dot length, k plus plus. This time we're going through both of them in the same order. We want to copy this guy into bucket 0 of this guy into bucket 0 of this guy. Bucket 1 of this guy into bucket 1 of this guy. Bucket 2 of this guy into bucket 2 of this guy. So on and so forth. We don't need to worry about overwriting this because we've preserved the contents in this new array. We also know that we can use k for both of these guys because they're the exact same length. We know they're the same length because we created them to be the same length. Make sense? So, the array that we're overwriting is I. We want to replace the contents of this guy with the contents of this guy. So we're going to say I at bucket k gets temp at bucket k. So k started off at 0. So we get a new version of k, started off at 0. Is 0 less than, do we use I? Is 0 less than I dot length? What's the length of I? This particular example, the length of I is 5, right? All right, so is 0 less than 5? It is. What are we going to do? We're going to set I at bucket k equal to temp at bucket k. So I at bucket 0, because that's k, is going to be equal to whatever is at bucket 0 of temp, which is an O. Then add 1 to k. K becomes a 1. This is where we're adding 1 to k right here. Okay? Is k less than 5? K less than I dot length? It is. So we're going to do this again. I at bucket k, so I at bucket 1, is going to be equal to temp at bucket 1, which is an L. K is a 2. Is 2 less than 5? Yes. I at bucket 2 is equal to temp at bucket 2. So we'll overwrite the L with another L. K becomes 3. 3 less than 5? Yep. So we'll say I at bucket 3. I'm sorry. Yes. I at bucket 3 is equal to temp at bucket 3, which is our E. Then we add 1 to k. K is now 4. 4 less than 5? Yep. We'll say I at bucket 4 is equal to temp at bucket 4. Sorry. There's our H. K becomes 5. Is 5 less than 5? Nope. So we're done. If that method ended right now, all of these variables die. Correct? Because they all had a local scope to this method. But we still have one variable that points up here in memory. And did we in fact change real memory to be equal to whatever originally was backwards? Make sense? And do you see how drawing this picture allowed us to see it? We saw what we were doing. We saw that if we just set I equal to temp, that had no impact on our variable from main, AR. So it wouldn't have changed. But because we copied the contents back, we were fine. That makes sense?
So why didn't you just like say I at bucket 0 is equal to the char instead of making a loop? Or why didn't you just like hard code that in there?
Well, because this is a method, and a method is a reusable chunk of code. It should work for any character array I pass it, not just this character array. I should be able to change this to elephant and have it still work. That makes sense? So methods are reusable. Never hard code something into a method. Methods work on the generics. This takes in any character array. It works off the length of that array. It works off the length of that array. Okay, we're always talking about it in terms of the generics. Okay, array, how long are you? It's going to have some length. In this example, it had a length of 5. An elephant, it would have a length of 8. So on and so forth. Okay, but the important thing here, for those of you that struggle with this, you have to draw these pictures. You have to solve this. Okay, you have to solve this first. You have to understand the solution before you can go write code to do it. Every one of you, if I gave you a bunch of blocks that had HELLO on them, and I told you to rearrange them backwards, you could do that, right? I can give that to a 3-year-old, and they can probably, well, 3-year-old's close, but you get what I'm saying. 5-year-old, definitely. 5-year-olds could definitely do that. They'd probably throw the blocks, but eventually, once you got them calmed down, they would be able to put them backwards. So really, I've given you a problem that a 5-year-old can solve. But the problem that you really had to grapple with is breaking it into the 2 steps. Solve the problem first, which every one of you could have done. But then understand that solution. Go back to day 1 of class. We talked about human beings are problem solving. We're so good at it that we forget how we solve problems. We just do it. And all of us want to sit there when it comes to programming and just do it. It's like, well, we're just going to dive right into the code. Well, that's a prescription for failure. You're not going to be able to do that for a while. Eventually you will. Eventually you'll be able to just sit down because you'll be able to visualize problems of this size. This is not a hard problem long term. But right now, you're still getting the gist of everything. So drawing the pictures and understanding your solution before you go and start writing this foreign Java language to represent it is very important. Make sense? Okay, so if you're struggling with these assignments, you have to draw pictures. You have to. Absolutely have to, especially when we get into pointers like this. Because it's so easy to lose track of what points to what and what still is equal to what and that kind of stuff. Okay, and remember, the whole point of this assignment was not only to drill us on arrays, but also to deal with this idea of variable passing. We can pass something by value, or we can pass something by address. In this particular case, when we passed in that array, when we passed AR into our method, which got stored into I, we passed it by address. That is, I and AR both pointed to the same place in memory. Make sense? So we did not need to return anything from reverse array. The alternative to this is, let's say I did not have this secondary for loop to copy everything back. let's say instead I said I'm going to return a char array. So after I built I backwards in temp, I can then return temp, which is the reverse of that array. Correct? And then I can say AR is equal to whatever gets returned from this. Now let's see the difference of what just happened. So in this case, well, pos and k, these things were used. So we built temp, temp was reversed. The reversed version of this guy. Here, let's just put this back. All right, so here's AR and I initially. Here's temp, we built it backwards. Then we returned temp. And what did we do? So we returned the char array temp, which returns a pointer, correct? The value of temp is what? 200. So this method right here boiled down to the memory address associated with temp, which was 200. And what did we do with that memory address? We stored it in AR. So we set AR, overwrote AR's original pointer to be equal to 200, which effectively made it point to this guy. And remember, when that method ended, I was a local variable of that method, right? This variable right here lived and died with this method. It was only around as long as that method kept going. So when that method ended, I disappeared. And then when we said AR points to the same thing the method returned, what's still pointing up here? Nothing. It has a 0 pointer count now. Nothing points to it. So Java has something called automatic garbage collection, which will come through and clean up this mess. Nobody can use this anymore because nothing points to it. So we're going to go ahead and free up that memory so somebody else can use that free memory later for another variable. Make sense? So we could have written this method this way by returning a value and then setting AR equal to that value, but specifically for this assignment, I said you could not return a value. It must return void. So you understood you were working with real memory. Okay? And that's why the original way we did this actually modified AR in place. We changed this guy up here because we had a synonym to him through I. We didn't have access to AR inside the method. AR had a local scope to main. So here's this local variable AR. It's only accessible from this point forward inside of this method. Inside reverse array, we do not have access to AR directly, but we indirectly have access to it through this local variable I, which happens to point to the same place in memory as AR pointed to, because we passed that array to this method. All right, so questions about any of that? It's very, very important that you understand all those mechanics we just dealt with. I'm okay with you still struggling and solving the problem, but you need to understand those mechanics. You need to understand the mechanic of creating a variable and then passing that variable into a method, and how this handoff, AR, gets sent into this guy. So this guy points to the same place as this guy. So inside here, the way we access AR is through a variable called I. All that is very, very important that we understand that. So ask your questions now.
So when you're throwing a variable into an array, it always has to be an int.
Say that one more time.
When you're throwing a variable into an array,
Throwing a variable into an array.
like how you have with the array and then pause.
This guy?
Yeah. Like,
You're asking, does this always have to be an int?
yeah.
Yes, because we're accessing the indexes of that. Bucket 0, bucket 1, bucket 2, bucket 3. That's how arrays are built, just like strings. So this is equivalent of saying if temp was a string, temp.char at pause. Except strings are read-only, so we can't actually set an individual bucket of a string. But yes, this, what's inside the square brackets, will always be an integer because we're accessing a particular index within the array. If we were dealing with an older language like C or C++, we could actually forego that syntax. And we could have written something like temp plus pause time size of char equals I at bucket K. Something like that. This is ultimately going to boil down to a memory address. Temp had a base address of 200 plus, let's just say pause is 2 right now. 2 times size of char. A char is 2 bytes, 16 bits. So 2 times 16 is 32. But we're actually doing this as 2 bytes. So 2 times 2 is 4. So this is going to say memory address 204. 200 plus 4 is 204 equals this. Bucket 2 of this guy is memory address 204. So that would have worked in older languages. Java does not support that syntax. Okay? But these two lines, in terms of memory, are equivalent. Okay? This is called pointer math, which Java's gotten rid of. Or really, abstracted away from us, since Java handles everything as pointers. They took away that special syntax. But I would still say it's important to understand this idea of pointer math, because we really need to focus on this concept of memory. Okay? That's why it's so important to draw these pictures for these assignments. These pointers get confusing real quick. Okay? It's not that they're difficult. They just get confusing. And if we don't visualize it this way, we're going to have problems keeping up. I promise you, eventually, you'll be able to solve a problem like this without drawing pictures. But there's bigger problems that I have to draw pictures for. You know, we all are going to have our limit of what we can kind of juggle in our head. You know, if you're a carpenter or something like that, you can build small projects without doing a whole lot of design, correct? When you're a beginner, you have to do the design because you don't know what you're doing. But when you've known what you've done and you've had some experience with it, you can do those small projects without that. But everybody's got their limit. I don't care how much experience you have, you're probably not building a house without design, right? There's too many pieces, you know, too many things that are going on in order to pull that off. Just like somebody who's a beginning carpenter probably isn't building a house even with a design. It's just not happening. I mean, it might be able to put something together that would stay up, sort of, but it's not going to be competent by any stretch of the imagination. Okay, so other questions about this before we look at the other assignment? Okay. Did you have diarrhea?
No.
Oh.
Drink a lot of coffee.
Oh. All right. Keep me posted. All right. Other assignment was to, what was it called? Count occurrences?
Most occurrences.
Most occurrences? All right. So we were supposed to write a method that returned an int called most occurrences. Did I spell it right? And this guy takes an integer array as a parameter, right? And here, just for our sake of our sanity, I'll call this guy, call it the ints. Okay? Just so you kind of understand that we don't have to name all our variables with single letters or something like that. So I'm sending it in a collection of integers. I'll call it the ints. All right. Now, notice this guy takes in an integer array. Can't pass it my char array. Need to pass it an array of integers. All right. So this guy's going to take in an integer array, and it's going to return the int from this collection of integers that occurred most often. And in the event of a tie, it didn't matter which one you returned. Because depending on which approach you took to solving the problem, you may have, if you started at the end, you might have a different winner than if you started at the beginning, something like that. So if two different numbers showed up 3 times, it doesn't matter which one you return. All right. So let's draw some pictures. I'll give us another slide. A little bit bigger array this time, right? Just as our example. Oh, I'm going to finish doing this and somebody can tell me what's wrong with it. So all of you right now should be thinking about what's wrong with this. One, 1, 3, 5. $19, 41, 35. So there's my array AR. It's going to be an integer array, and I'm going to go ahead and fill it up with 1, 1, 3, 5, 1, 9, 4, 1, 3, 5. And that's going to create something. Let me put in my variable names here.
What's wrong with talking about that right there?
Yep. So that's going to give me something like this. So, if this is AR, and AR is an array of integers, what's wrong with this?
The red one. 5, 6, red one needs to go.
Oh, hold on. Not my intended problem yet. There. Now what's wrong with it? Thought you told me you understood this memory stuff.
Like chars need like their own memory addresses, but they just don't.
It's contiguous. 100, 102, 104. All arrays. All arrays need to be contiguous.
Is it because
Dumb question, but a good question.
integers?
Every single array, 100% of them. It's a rule of arrays. They have to be contiguous. Go ahead.
Isn't integers 8-bit? So it don't.
You're on the right track, but integers are not 8-bit. How big is it? How big is an integer? If it was 16, this would be right. How big is an integer?
32 bits.
32 bits. Or 4 bytes. Right? Chars are 2 bytes. Ints are 4 bytes. This is wrong because the amount of memory I took up for this guy is only half of what it should have been. This should have gone to 100, 104, 108, 112, 116. I needed to jump by 4s, right? The new keyword would have handled that for me. It would have known I needed to go get enough memory to hold this many of these guys. It would have gotten us enough contiguous memory. But as I represented it as our char array because of what I copied. All right, so 112, 116, 120, 124, 128, 132, 136. All right, a little bit better now? All right, so this accurately represents an array of 10 integers, assuming the base address was 100. I keep using that because it's a good, easy for us to count number. Realistically, you can have some weird hexadecimal value that's just some random place in RAM. But for our pictures, 100 works. All right? So that's what our integer array looks like. And again, just as a reminder for this, if I say AR at bucket 3, that's the same thing as saying AR plus 3 times size of int, which is 100 plus 3 times 4 bytes. 3 times 4 is 12, so that's 112. Bucket 3 is at memory address 112. See how that's working? That's why it has to be contiguous, because we can mathematically go to the spot. Arrays are fast. Next semester, we're going to be dealing with arrays are fast, but linked lists are slow, but more memory efficient. Go ahead.
Is there a way that you can use that math equation to rewrite the buckets?
In older languages, yes. That's what I was saying down here with this line.
Yeah.
If we were dealing with a language like C, C would allow us to use these two lines interchangeably. We can directly write memory in a language like C by doing pointer math. Go to memory address temp plus pause times size of char. Go to that memory address and place this value there.
Okay.
So in an older language, it would let us do that. Java does not expose that to us. Java doesn't directly expose memory. So because of that, we are in fact writing real memory with this line right here. It just is more compact. So we're doing the same thing, it just looks less intimidating. And realistically speaking, if you're ever looking at old code and you see somebody writing something like this, in my opinion, it's not the best way of doing it. I think it's harder for the average developer to read. And even beyond that, I would say, wouldn't you say for any developer that this is more difficult to read than this? I would say for everybody. So really, they're just kind of showing off with this just because you can. Same thing when somebody uses the I++ or ++I in line with a statement. It's not wrong. Maybe it saves you sometimes, but realistically speaking, it's never required. And I'm always an advocate of writing code that's more understandable, even if it takes a couple more lines. Because you have to understand that you aren't going to be the only person ever looking at this code, or likely won't always be the only person looking at this code, especially in industry. Okay, computers are fast. Nobody cares if your code is 2% quicker. Okay, or we have plenty of storage. Nobody cares if your code is 10% more compact, takes up 10% less space. Nobody cares. Okay, nobody's impressed. I actually had an argument along these lines with one of my company's developers a couple of weeks ago. We were interviewing a new developer, and I gave him a little programming test for competence. And so my developer's like, oh, well, I would do the math this way, and all this, you should have them do it in the most efficient way. It's adding numbers. I'll tell you what, let's do it in the most inefficient way, and we'll race against your efficient way. And I bet you the human eye won't be able to tell. Nobody cares. Nobody cares if you're, a math genius. You can come up with a weird algorithm for summing a bunch of stupid numbers. Write it so that the average common person can solve this problem. So that when the developer next to you, has to use your code as an example or has to go and fix your code, they can understand what the heck you were writing. Okay? Something that we don't do too much is we don't put too many comments into our code. You should. You should always comment your code when you think it requires comments. In general, I think having code that's self-documenting is important. Write code that's understandable. If you have an aspect of the code that can be a little confusing, Put a little comment. Say, this is what this chunk does. Just to give them a heads up, whoever's going to read this later. Or give you a heads up when you step away from it for 6 months, then come back. Okay? So, don't show off. Nobody's impressed. All right? It used to be a job security thing. If you were the only one who could read your code, then they really couldn't get rid of you. But how about just don't show off and be good, and that'll be good job security. Okay. So, here's our array. We're going to pass this in to our most occurrences, and we are going to return, in this case, which of these numbers occurs most often? 1. Every one of you in here did that instantly, right? We just glanced at it and said, oh, well, I see 4 ones in there. I don't see that many of any of the other ones. 1 is the winner. Okay? This is the point where I want you to pause. Every single time that you're trying to solve a problem, you have to pause right there. First of all, you feel good about yourself because we are so good at problem solving, we didn't know how we did that. Now slow down and decide, how did I do that? All right? How did we magically glance at that and come up with the right answer? Okay? How did we do that? Well, we walked through. Maybe we did it this way. Maybe we looked at the first one and said, oh, here's a 1. Let's see how many of those there are. We have 1, 2, 3, 4 of those. Now, realistically, I probably looked at every character, right? Is that a 1? Yes, that's 1. Is that a 1? Yes, that's 2. Is that a 1? No. Is that a 1? No. Is that a 1? Yes, that's 3. Is that a 1? No. Is that a 1? No. Is that a 1? Yes, that's 4. Is that a 1? No. Is that a 1? No. Out of stuff to look at, I have 4 ones. Current winner, right? Okay, 1 is my current winner. Here we go to this guy. Well, I can count 1s again, but as a human, I know I've already looked at the 1s. But you know what? Just for the sake of argument, let's go ahead and count the 1s again. This the 1, yes. This the 1, yes. We come up with 4 1s. Okay? Does 4 beat our current winner of 4? Nope, it's a tie. So we'll keep the current champion of a 1, even though this was also a 1. Now we go to this guy. 3s. Is this the 3? No. Is this the 3? No. Is this the 3? Yes, that's a 1. 3, no. 3, no. 3, no. 3, no. 3, no. 3, no. 2. Or 3, yes. 3, yes. 3, yes. 2. So good at problem solving, we get ahead of ourselves. So 3, yes. That's a 2. 3, no. So 3 and 2. Does 2 beat our current champion of 4? Nope. Move on. Here's a 5. 5, no, 5, no, 5, no, 5, yes, that's a 1. 5, no, 5, no, 5, no, 5, no, 5, no, 5, yes, that's a 2. Does 2 beat a 4? Nope. Not a winner. Here's a 1. You got 4 of those. Okay? Does 4 beat 4? Nope. So we're not going to replace our winner. Now we're at 9s. 9, no, 9, no, 9, no, 9, no, 9, no, 9, yes, it's a 1. 9, no, 9, no, 9, no, 9, no. 1. Does 1 beat a 4? Nope. Now we're at 4. 4, no, 4, no, 4, no, 4, no, 4, no, 4, no, 4, yes, that's a 1. 4, no, 4, no, 4, no. Does 1 beat a 4? No, not a winner. Have a 1. Got 4 of them. Does 4 beat 4? Nope. We get a 3. Does 2 beat a 4? No. We're at a 5. Does 2 beat a 4? No. We're out of crap to check. Let's go and look at the standings. Who won? With a count of 4, the winner was 1. Return it. That was a lot of steps that we all did instantaneously, right? At a glance, we did all of that. Because we're smart. We're really good at this stuff. We're so good at it that we forget how we solved it. We just did all of that. At a glance. Now that we have an algorithm, a solution to the problem that we can explain to somebody else how we did it, now we can write some code that mimics that. Okay? So what are some of the things that I kept track of there? If we think of it like a play. Well, I had a current winner and I had a current winner count. I had to keep track of 2 things. Who was my winner and what was their score? All right? So I'm going to create a couple of variables here. Winner and winner count. There's winner. There's winner count. All right. Now, I'm going to go ahead and start winner off at my very first character. My very first integer, rather. I know he's going to be the original winner. He might not be the ultimate winner, but since he's the only one I've looked at so far, I know he's the winner. Now I need to build up his count. Now, I don't want to overwrite winner with the current guy I'm looking at. Correct? I don't want to do that. So I'm going to need another variable. Current contestant. How about just current? Okay. How about just current? Current contestant. All right. So our maybe actually we start winner off. We could say it's 0, and we start winner count off at -1. It's reasonable enough for this example. All right. We run into a problem if it takes in an array that doesn't have anything in it, but we'll assume it has something in it. So we don't have a winner yet, and winner count is currently a -1. So we know the very first guy we check will beat a -1. Make sense? See, power up. All right, so we're going to check current. I'm also going to need a current count, because I don't want to overrate my winner count. With current count, do I? All right, so current count's going to start off at 0. The current guy I'm looking at is a 1. And this guy is at what position? Well, I need to keep track of the position. I'm going to need another variable. Maybe we call this guy pause. Pause starts off at 0. That's the first guy I'm going to look at. So at my array, at bucket pause, at bucket 0, I have my current contestant, which is a 1. Okay? Now I'm going to go through the entire array, counting the number of currents I see. That's going to be a loop. So I'm going to loop through this entire array. I'm going to count the number of 1s I ran into. We know that's going to be a 4. All right? Does 4 beat a -1? It does. So we'll go ahead and replace the -1 with a 4 and our current winner with current. Then we're going to increment pause. Go to bucket 1. Current guy is a 1. Current count is a 0. Loop through an entire array. Count how many 1s there are. We know we're going to come up with a 4. Is a 4 greater than a 4? Nope. So current winner stands. Increment pause. Pause is now 2. Current guy we're looking at is a 3. Reset his count to a 0. Go through, count the number of 3s. We know we're going to end up with a 2. Does 2 beat a 4? Nope. Move on. Pause is now 3. So pause goes up by 1 each time. Current will become a 5. We reset the current count to a 0. We count the number of 5s. We get a 2. Does 2 beat that? Nope. Seeing the solution here? Okay. So now that we understand our solution, we can write this method. I'm going to need 5 variables to pull this off. And actually, there'll be a 6th because we're going to have a variable associated with our loop, probably an I. I will go from 0 to 9 in this case, counting the number of currents it runs into. So let's go ahead and define our variables. We need current, current count, pause, winner, and winner count. So int current count, int pos will start off at 0. Int winner, and we could set winner equal to, what do we say, 0. Int winner count is equal to a -1. Make sense? Now, we can say, while pos is less than the ints dot length, and you could have done this in a for loop as well. I just happened to write it as a while loop. That is, as long as we have more positions to check. In this case, I need to check how many bucket zeros there are, how many bucket ones there are, how many bucket twos there are, all the way up to the end of the array. Okay? So as long as pos is less than the end of the array, I know I have another current potential contestant that could beat our winner. Each time through, I'm going to set current equal to the ints at bucket pos. So that's my current contestant. I will set current count equal to 0 because I haven't found any yet. Now I'm going to write a loop that goes through the ints and counts how many of current I see. For int I is equal to 0, I is less than the ints dot length I plus plus. This is our stock loop for going through every element of an array in this case, pretty much identical to the one that goes through every element of a string. Okay? And each time through I'm going to say if the ints at bucket I is equivalent to current. If I found an instance of my current, if I found somebody that matches my current contestant, then I'm going to say current count plus plus. So I'll loop through every element of the array, and each time I see a match, I'll increment our count. At the end of that for loop, I now have the number of occurrences of my current contestant. I want to compare that to my current winner. If current count is greater than winner count, if that's a true statement, then I'm going to say winner count is equal to current count. Winner is equal to current. Only if I have a new champion. All right? Every single time through, I need to increment pos. Pos needs to become 1 bigger than it used to be. So I can check my next contestant, my next contestant, my next contestant. Make sense? So when I get to my next contestant, I set my next contestant to current. I zero out the current count, spin through the entire array counting the number of occurrences. If the number of occurrences beats our current winner, I replace the current winner and the current winner count, move on to the next contestant. Once I've finished checking all of our contestants, that's when this while loop is done, I can return winner. And that should have our answer. So in this case, our winner was 1. And it just happened to have a count of 4, which we don't need at the end. So here's my array. Class method or instance method? Class method. How do you know? Static. How do you call class methods? Name of the class in which the method was defined. So I'll say system.out.println hw. Most occurrences. We'll pass it AR, our array, and we know for this particular array, 1 occurs the most number of times. Correct? So this should print out a 1. Again, this is how things resolve. So I'm going to call this method. This method's going to go through, do this whole rigmarole here, and ultimately boil down to an int. So what I have highlighted right here ultimately will become some integer, which I will then print out. I'm not storing it anywhere, I'll just print it. So this should print out a 1 for us. Ruh-roh. Oh, not my fault. Example. Told I advertised it wouldn't work in Java. There's our 1. Okay. And if I want to change up, so this gets back to what you were saying. If I change up my input, so here we'll put in, fine, doesn't matter. Put a 67 in there. Okay. So I have a lot more inputs now, and I should have a new winner, or threes are a new winner now, right? So I changed nothing else other than my input. And now the winner should be a 3. Because I wrote the code generically to work on any input. That makes sense?
How would you write it so that if there is a tie, you could display both numbers?
Well, you really can't in this case, because this guy returns a value. Returns a single value, doesn't display it. We are only choosing to display it. If you potentially had multiple champions, that's what you're saying. You could, well, actually, why don't you tell me? Do we have a way of returning more than one value inside of a single variable name?
Couldn't you store the different winners if they were equal, if the count was equal?
You certainly could. Where would you store them? How do we store stuff? Based on what you know now.
Inside a memory address? Or using a variable?
Okay, what kind of variable? What kind of variable do we have access to right now that can hold more than one same type value? An array. So I could have this guy return an array of winners, right? Now, one thing we probably have to do is we probably have to be a little bit smart about it, because remember, arrays, we get to create them once. So we'll probably create an initial array that is the length of what? The entire original guy. Potentially, we have a whole bunch of unique values, so we have, in this case, 10 winners. So actually, we have more than 10 right now, but you know what I'm saying? So we'll create an array of potential winners that's the same size as the original input, because that's the number of potential winners we have. Then we'll probably partially fill it up with the winners we run into. Then we'll create a new array that's the appropriate size, copying all the exact number of winners into that, and then return that array of winners. So that's one way you could have pulled it off. Based on what we know right now. The only way we have of storing more than one value right now is through an array. Make sense? Okay, so any questions about any of the stuff we did today? I'm about to give you another homework assignment. You get to draw pictures. What's up? Can you color? No. No, yeah, you got a program. I'm gonna write your method header for you, and then you get to solve it. But I'm encouraging you to solve it intelligently. All right.
Are you recording this?
Yeah, it's recording.
Steven would be really upset if you didn't record it.
We probably wouldn't care. All right. So you're going to write a method called sort. And if this were the input, sort should have 1, 1, 1, 1, 2, 2, 3, 3, 3, 3, 3, 3, 3, so on and so forth, right? Should reorder it so that it's in ascending order, from smallest to largest, storing the final result. So you're going to want to print it. So we'll print it. Then we're going to call sort, passing it AR. Then we'll print it again. And the second time around, it should be sorted. Right now, it won't be. But we have an issue. Why is this showing up as a memory address? What does that tell us? AR is what kind of animal? It's an integer array. Right? Integer arrays. System.println does not know how to display an integer array. So you'll have to write a little method for displaying. It goes through and, with the for loop, displays each integer in that array to prove that you got it right. It knew how to display char arrays. So to display an integer array, I know we're out of time. Let me just write this for you real quick. I'm sure you won't mind. All right, so that should display and we'll see right now it displays them both in the same order.
So when you just want to take out the LN if you want it all in one line.
Yeah, I would say maybe don't put it all in one line since sometimes you have doubles like this, but whatever you want is fine. Like I have a 2-digit number in there. Doesn't really matter as long as you're able to test whether it works. So your sort method should do some magic in here. All right, remember, Bible study today, free lunch, go to the cafeteria, sign in, get your tray, take it down to the, what's the name of the room?
Terrace room.
Terrace room. Free lunch, God and grub, boom, boom, boom. Psst. All right. And I'll put this up on Angel.